Hello friends, in my this video I am going to discuss how you can print this kind of star pattern in Java. Okay, so obviously it is clear that this is nothing but you can using the concept of matrix and its left and right diagonal concept, and you can print this, right? So for first row, first column, last row, last column, right diagonal, left diagonal, all the elements should be printed. Rest all space or nothing has to be printed. That's all, right? So what to do, you should have a clear idea in the algorithm on the left and right diagonal matrix. So if you know, well and good. If you don't know, please go through the link given in the description. Okay, like here in my previous video I already discussed how to print star pattern for the right diagonal, and here it is the code. This video link also I will provide in the description. If you want detailed explanation, you can check there. So import java.util.scanner, then class WAP we have defined public static void main string args. I have just changed the class name here. In my previous video you may get different class name. Now after simulating, let me simulate first the code. Already I explained in my previous video about this code. Java C WAP dot Java, then Java WAP. See, enter the dimension of the matrix. If we give 8, this kind of 8 stars diagonal, which is situated diagonally in the right diagonal of the 8 cross 8 matrix, it is printing, right? Suppose you are giving 4 stars, then 4 star will be printed according to right diagonal. Okay, so that is the basic idea. Now just one little bit modification just I want to mention. See, as you know, for right diagonal elements we no need nested for loop. By using only one for loop implemented for the row and one variable which we can initialize as k equal to l minus 1, and we will decrement that, we can easily make, using these two things we can easily make the right diagonal elements. For right diagonal elements we don't need nested for loop, right? But for the other elements we require. So see, if you are using the concept of right diagonal elements in your program, then what you do, k equal to k minus 1, which we generally do in the right diagonal matrix, don't write inside this for loop which we have implemented for the columns, because generally for right diagonal we never write this. So for this particular program it is clearly working, but sometimes you may not get this easily. Later I will show you one issue related to this. So what you can do, after the end of this for loop for the j, after that you can define here. Okay, then that will be easier. So obviously what will indicate that this particular k equal to k minus 1 is independent of for int I equal to 0, I less than I plus plus. Okay, basically that's what, right? Because we know we don't need nested for loop for the right diagonal. Let us check whether it is simulating or not. See, here also it will simulate. Suppose let me give 7. See, 7 stars are in diagonal fashion, it is printed. So you just keep this concept in mind, that if you are dealing with right diagonal element but you have to use nested for loop, then you decrement the k which you initialized as k equal to l minus 1, or the last column for your particular square matrix. You decrement that outside of the for loop which you are using for the columns or j loop. Okay, I hope you have understood this. Now let us go for today's code. So as you understood the algorithm, for first column, first row, last column, last row, for left diagonal, right diagonal, star has to be printed. So see, here I have written the program. Import java.util.scanner, then class WAL, public static void main string args, then scanner obj equal to new scanner system.in. We are creating the object in the scanner class. Then system.out.println, and enter the dimension of the matrix. You can give some other message also. Int l equal to obj.nextInt char a equal to new char l cross l, same like whatever I have discussed in my previous video. See, int k equal to l minus 1. Then two for loop, there is nested for we are using for what? Nested for we are using for rows and columns. Then if I equal to 0, a of ij equal to star, that is for first row. Else if j equal to 0, then print star, that is for first column. Then else if I equal to L minus 1, A of ij equal to star, that is for last row, and else if j equal to 1, A of ij equal to star, that is for last column. Else if j equal to k, A of ij equal to star, this is for right diagonal. Else if I equal to j, that is for left diagonal. Okay, star has to be printed, else we are not writing anything, it will automatically do. Then see here we ended the for loop for j or for loop for columns. Then outside the for loop for j we are writing k equal to k minus 1. We are decrementing the counter. Then for int I equal to 0, I less than L, I plus plus. For int j equal to 0, j less than L, j plus plus. System dot out dot print A of ij, system dot out dot println. Okay, that's all. Let us check whether our code is working or not. Java C WAL dot Java, then Java WAL. Enter the number. Let me give some bigger. Suppose let me give 40, and you check. See here our desired matrix is created. Okay, you can check for other inputs also. You can give smaller input like 20. See one, this kind of beautiful matrix is created. Now see the program issue. Suppose what you do, you define k equal to k minus 1 instead of here. If you define in this particular portion, that is j equal to k, that is for right diagonal, whatever we are writing at that particular part, if you write and if you save this, then go to command prompt, then cd java, then java c WAL dot Java, then Java WAL. See, enter the dimension of the matrix. Let us give 20. See, only the matrix it is printing, but it is not printing the right diagonal. That is the issue. Now let us try to understand why it is not printing so. Okay, because you should understand the reason. See, initially we have defined int k equal to L minus 1, right? And here for the last column we are here what we are writing, j equal to L minus 1, right? That is, this is defined for last column, but here we are not decrementing the counter k. Although k is belonging to L minus 1 value, but we are not decrementing that. Instead of else if j equal to k, for other cases this k equal to L minus 1, this j will never get the value L minus 1. Just try to understand, for a particular I value, j equal to L minus 1 already arised earlier, and we have not decremented the k value. Now when I is changed and j is also changed, now if you write j equal to k, that will never match with k. So if you want to write k equal to k minus 1 here, you have to write k equal to k minus 1 here also. Now if you press Ctrl S, now you go to command prompt, see Java C Java, suppose let me give 20. See, now also it is printing, but then also in distorted fashion. So what I say, don't go this much complexity, remove all these things and just remember this concept, that whatever you are using for the right diagonal, as in right diagonal we never use nested loop condition. So after coming out of the for loop for j or for loop for column, outside that you define the counter decrementation. Okay, now let us simulate once more to check whether our code is working or not. So suppose let me give 50. See, this is our desired matrix, which is pattern is perfectly working. Okay, so this concept is very important, that although if you are dealing with right diagonal matrix and you have to use suppose you have to use in your program, you must have to use nested for, then don't forget to give the decrementation of the counter value outside the j loop, okay, but inside the I loop. Obviously this is very important concept. I hope you have understood this. I'll post the same code in the comment section of this video, and to check my previous videos please go through the link given in the description. Okay, thank you for watching.